off, my name is Rebecca Bornheimer. I am a research analyst here at PAI. My original background is in pure and applied mathematics, but I have been at PAI for the last 5.5, almost 6 years. I've been involved in a number of Microsoft Excel-based models. So you could consider me maybe a basic, experienced Excel modeler. I have not been directly involved in the programming of heRo3, though I have been providing some basic input during its early development. So really, I am like the majority of the modelers on the call today who are used to building models in Microsoft Excel and might have little to no knowledge of R programming. So hopefully this workshop today can help some of you start modeling in heRo or clarify for others who have already been working in heRo3, and hopefully help everyone's programming time. So first, I do want to remind everyone on the line that this is workshop number 1. If you participated in workshop number 1 last week and you meant to participate in workshop number 2 today, please send an email to Arti. She's a colleague of mine with me here today. Her email is going to be asharma@pai2.com, and she will be able to provide you with the direct link to the appropriate WebEx if you meant to go to workshop number 2. For those of you who are wondering why are they being hosted at the same time, there will be a second iteration of workshop number 2. We just wanted to get everyone caught up with both workshops. All right, and then finally, just a brief disclaimer, we are recording this workshop. It will only be used for the purposes of training other heRo3 users. But if for some reason you feel uncomfortable having your voice recorded or anything like that, please feel free and use the WebEx chat function to ask questions instead. Either directly to the PAI host or the open chat. It would be easier if it's sent to everyone. That way RT can possibly handle those while I continue presenting, excuse me. Okay, so next having to do with questions about anything covered, please feel free to ask them during the presentation. I believe some of you have possibly less knowledge about heRo than others. A number of you did participate in the original heRo3 training. Others have just been provided the deck, and then I don't know if there's a final proportion of you who have possibly not had a chance to look at the training deck. I know a few people have joined the call since I've been speaking, so just to remind you all, this is workshop number 1. If you're looking for workshop number 2, please email asharma@pai2.com. and that the workshop is being recorded. All right, so then agenda for today's workshop number 1. First, we would like to start off with just some of the updates and platform development that has happened to heRo3 since the pilot study launched, as well as some tips and tricks to help you develop both the Markov and partition survival models in heRo3. And then finally, an open question and answers portion at the end of the call. If for some reason we run out of time towards the end, any questions can be sent to myself or RT or the heRo support team, which the email will be at the end of this deck, and we will follow up on any questions that do not get answered during this presentation. Okay. So, starting off, updates on platform development. So pilot testing for heRo3 began in late November with the initial release of heRo3, and it only included the functionality for Markov cohort models at that time. We did have a major update in late December that enabled partition survival models to be built and run on the platform. And then the latest update added functionality for calculating value-based prices. And this update also added ability to export tabular results data as CSV or XLS files, as well as functionality for exporting models as RStudio projects that you can then run locally in R. So exporting models as RStudio projects is a bit more for an advanced user, but maybe we have a few of those on the call today, I'm not sure. So moving forward, we also expect that pilot testing will continue for another 4 to 8 weeks. And during this time, heRo3 development will continue. Additional features and functionality will be brought online over this time period, probably not all at once. But this will also include PSA and PSA modules, which we know users are hoping to get sooner versus later, as well as report generators and other new features. Finally, I just want to thanks again to everyone for participating in this pilot study. The feedback that has been provided to date has been invaluable and has helped us make changes to the heRo3 platform already. We hope that you will continue to provide us with comments and your thoughts. We are also always here and ready to answer your questions and solve your problems. So there are a number of people who have reached out to heRo3 support asking specific questions for how to do things in heRo3 as well as how to do things directly in their model. And those who have had issues with their models have sometimes exported them and sent them directly to PAI. We will talk about exporting models in a few slides. So now that we know about the updates, hopefully we can focus on some tips and tricks and other hopefully useful advice to develop models in heRo3. So when you go to the heRo3 website, you all have been provided a link specifically for your group. You will get to what is called the landing page. And what's good about the landing page is over on the left-hand side, just to let you all know, we will be working directly in heRo3 today. I just have a few screenshots at the beginning so we can continue in the slides. On the left-hand side of the page, it will always list what's new in these updates of heRo. So if you're ever wondering if things have changed or functionality you are interested has been added, it will come up in the blue box on the left-hand side. Now, for some of you who have not yet used heRo or have not yet gone to the landing page, the first time you go to the landing page, Google Chrome is going to ask you if heRo can store files on this device. Before you are able to actually start working and using heRo, you need to accept and allow it to save locally to your computer. Now, this is specific to the pilot testing phase of heRo. Once the official heRo platform is rolled out, files would be saved depending on which deployment you use. Either if it's enterprise deployment, items will be saved behind your firewall, or if you do cloud-based deployment, it would be stored in the cloud-based server. So, going back here, if we ever forget to accept anything, or if you ever need any help in heRo, there is this question mark in the upper right-hand corner that takes you to the heRo Guide and FAQs Confluence page. So for this help, we know that heRo3 is a completely new and different way of building and running CE models, and a number of you have not used it yet. So again, if you encounter any difficulties or have any questions, The first place to look, if you don't want to wait on one of us to respond to you, is in the heRo3 guide and frequently asked questions. From anywhere in the platform, you can access this information by clicking the button in the upper right-hand corner. So again, that is this question mark up here in the upper right-hand corner. So let me switch to heRo3. Now I am actually in our Google Chrome browser, excuse me. And once you go to the landing page, you are going to want to hit continue, which will take you to, and sorry, because I've already been working in heRo3, I can either start a new session or continue with what was already open. I'm going to start a new session because I personally know I have saved my models and the most up-to-date ones are saved on my Google Chrome cache browser. So I'm going to click no. So now we are in the heRo3 workspace. And in the workspace, you always have the option to start a new model. Right now, heRo3 can handle Markov cohort and partition survival models. You will have your models, which are the models that have been saved directly to your Google Chrome cache. And you will have model templates that we have provided for pilot testing. Okay, moving forward. Oops, I'm sorry. So again, from anywhere, but specifically here on the workspace, we can click our help icon, which will open a new window and take us to heRo3 guide and frequently asked questions. So we will come back to the heRo3 guide and FAQs throughout this presentation. When you first click on it, it will always take you to the Open HeRo, but on the left-hand side, you have an option of a number of different pages. One for workspace, one that calls up the upper toolbar, as well as all the stops on the heRo3 subway. So it's a good place to get a basic learning of heRo3 functionality if you ever miss a training or just want more clarification. Okay, so backing up your work. Now, this is how you would save a file to your model area in the workspace. So during pilot testing, your models and data are being saved locally in your Google Chrome cache. Now, because Google Chrome cache is typically used for temporary storage, to avoid inadvertently losing your models, we strongly recommend that you regularly back up your work. And by this, we mean in addition to saving the model, you should possibly export the model. When you export a model, this will export the model from the web browser and save it to usually your download location. So wherever what you download from Google Chrome, that location where it usually gets saved is where you'll find your model. In addition, every instance of Google Chrome has its own cache. So if you create a model on one machine, save it, and then later you open a browser on a different machine, it will look like you've lost your work. But really, the work was never on that second machine. So if you return to your original machine, you will still have the model there. Instead of using the slides, let's quickly just show in heRo3 how you might export a model. So I'm going to return to my open model, and in the upper right on our toolbar, we're going to go to the Save As icon. That's this dual sheet type looking icon. You'd click Save As, you would enter your file name. So for instance, we'll say example, author is Rebecca, and export model. You'll see the model has now been exported. Now I know my models go to my downloads location. If for some reason you have difficulty finding your models, your IIT might be able to help, or possibly look where if you download an article, where that's usually saved first. So one additional thing that's helpful with exporting your models is if you have an internal server that you can access from multiple different machines, if you export your model there, you can then import it when you're at your second machine versus your first machine. So it's a good way to handle, oh, I work on my desktop at work, I work on a laptop at home, but I want to work on the same model. Good way to just work with all of that at the same time. Again, it's just good to export models, so in case there's ever a bug and the cache gets cleared, you don't lose all your work. Please keep in mind that for the formal release of heRo, heRo will save your models and data either in the cloud or on a server behind your firewall, depending on the deployment you use. Okay. So an additional function to heRo that has been added, I'm not positive when, probably mid-December, is if you make an error, we now have an undo and redo functionality. So the undo functionality to roll your model back to its immediately previous state. heRo3 allows you to undo up to 10 previous actions, and redo lets you restore actions that you eliminated with undo. We will definitely use undo and redo as we go through some of the examples in heRo3 today, but those are also located in the upper toolbar. So now that we've done a little background on how heRo has updated since its original launch and how you can save your work and not lose it, let's dive a little deeper into modeling tips and tricks. Oops. We already are in tips and tricks, but now specifically modeling tips and tricks. For instance, time dependency in Markov models can become very important, and that's also what adds in complexity to the Markov models and sometimes make the Excel sheets a little harder to follow. So even simplest Markov cohort models can become unwieldy once mortality is assumed to depend on age. So we're going to look at a simple three-state model and consider how we can incorporate age-dependent mortality rates. And the simplest way to do this is going to be by copying and pasting your data into a table, and then using the lookup function in heRo to pull the data into your model. So the lookup function in heRo is very similar to the VLOOKUP function in Excel. So if we switch back to heRo, and I'm going to go back to our workspace, which is what looks like the folder icon, and I am going to open our time dependency model. To load a model, you're just going to click on the model, and now it's loaded. So again, this model, if we go to state, is a simple three-state model where patients are split into well, sick, and dead. It includes two strategies, a natural history strategy as well as a new treatment strategy. And over in tables, which you can find on the left-hand toolbar, in this little icon that kind of looks like a table, we are going to create the table, life table natural history. So again, the easiest way to enter your data into this table is to copy and paste. I know most of you work in Excel, so it'd either be copying and pasting from Excel or possibly a table in Word if the columns are set up correctly. And the best way to copy and paste is going to be using your Control+C key, C as in Carlos, to copy, and Control+V key, V as in Victor, to paste. Now, another thing to keep in mind is to pay attention to your column names. That is how we are going to reference the columns in this table. And specifically pay attention to if you use upper or lowercase letters. Now, heRo3, like R, is case sensitive. So we do suggest using all lowercase if possible, so that way you will never have to think, oh, did I use uppercase or did I use lowercase? So now, how can we reference this newly created life table? We're going to go to variables, which is the X on the left-hand toolbar. And we're going to look at the probability of dying while well. So we know we want to use the lookup function, but let's say we don't remember the syntax of the lookup function. What's the first argument? What's the second argument? I don't know. So again, if we go to Confluence, the HERO Guide and Frequently Asked Questions, and we go to Formulas in our syntax, there is a list of majority, if not all, of the functions that can be used in HERO3. So if I search for lookup, we will get a brief description of the function as well as its relative syntax.
One question here. Would it also be possible to reference without the lookup function in the usual R syntax with brackets and with dollar signs for the column names?
To use which one? I'm sorry, I didn't hear you. I heard double signs for the column names, but the first...
If instead of using the lookup function, would it be possible to state the name of the table and then a dollar and then the name for the column and then open brackets and close brackets in the rectangular brackets and then put some, the word of the column inside? I mean, in the classical R syntax without the lookup, or do we have to use the lookup function here? So the lookup function is not the classical R syntax, is it?
Yes, to be safe at this point, I would suggest using the HERO3 function, and in this case, lookup. I can definitely double check with our programmers and give you a definite answer after the call.
If not, I think it would be helpful if it would work. And sometimes I experienced when I try to enter equations that sometimes those equations were not stored. May it be that if I have a wrong syntax and I press save or return or whatever, that then the syntax is not stored in the cell?
I am not sure for why the formula would not have been saved unless sometimes you do need to press the check mark or enter. So if for some reason you were still entering the formula and clicked off, then right now that formula is not updated. It has not been updated until you hit enter or the check mark.
Okay, and if I hit the check mark and there's a syntax mistake, so sometimes I click the check marks and it didn't, I don't know why it sometimes worked and sometimes not. So I clicked this check mark and it wasn't saved. When I click the check mark, is there a syntax check, and does it only work if the syntax is correct?
So currently there is no syntax check. The user needs to check their own syntax.
So it might be if I, in this equation here, forget a comma or the last bracket, then it would save this wrong equation and later produce an error message when I try to run the model.
Correct. We are working on functionality to detect syntax errors, as well as clarifying the errors that pop up when you go to base case. So right now, if there was a syntax error, the formula would still be saved.
Okay, good.
Okay. So the second way to look up the syntax of a function that you would like to use is to start typing it in the formula bar. And for instance, the only function that starts with look is lookup. It then provides you with the description of the function as well as the basic syntax. So we can click on lookup or continue typing or hit enter. There are lots of options. And the first argument for lookup is the table that you want to reference. Now, let's say I don't remember what the table name is. So we can click on tables, and it is life table, life_table_nat. So if we start typing, it immediately comes up because we have created this table. So now we can reference it, and it will show up as a pill because it is a reference type variable within heRo3. So the next argument is, what do you want to match on this from the table? And we want to match on the column age. And we want to match when age equals the start age of the patients in our model, which again, since it's a variable, will come up and we can see as a pill. And again, since it's a created variable, the formula bar will suggest it to it. So we want start age plus model year, which is the years elapsed since start of the model. Now, irrespective of the cycle length that you choose, this will tell you then how many years are you into the model based on the cycle length. And then finally, okay, thank you. We need to set what value do we want to return. Now, again, heRo3, like R, is case sensitive. So if I was to capitalize value here, we would get an error when we go to base case. I specifically know this because I capitalized it yesterday and couldn't figure out why my model was broken. Then we figured it out. So value needs to equal, I believe, and we'll go check in our table, P-def male. So again, we'll go double check the table. Our column name is P_def_male.
Here in those tables, I realized it's possible also to put into the column names the space, for example. This may happen if you copy and paste in Excel. Is it also possible to use, well, column names, if you see those quotes, it's fine if there's a space for the column name?
You said you could...
Yeah, so if you would...
But
yeah,
it would be, you are correct in saying that would be a way to do a variable in heRo3, yeah, and it will not be properly referenced.
So currently it's P_def_male. If we would just put spaces there, does it work anyway, or does it require to have the underscore?
So all variables, like in R, can only include, they must start with a letter and may only contain letters, numbers, underscores, and periods. So if there are,
and this also holds for the column names of these tables. Okay.
It holds for the column names of the table because we are directly referencing the column names, yes.
Okay, thank you.
So finally, at the end of the formula, we will do now I'm sorry, if someone please do. Thank you. Bin equals true works in the same way as the range match in Excel's function. They're false for an exact match, while true looks for an approximate match. Now, we have created the probability of death on this lookup function.
Excuse me, we're getting a lot of background noise. If you're not asking a question, could you be so kind as to put your phone on mute? Thank you.
So now that we've created the transition variable, we'll go to transitions, and we want to set the probability of going from well to dead equal to P-def well. And since we created it on the variable sheet, it now will come up as a pill. You can either hit the check mark to save, or enter. Okay, so now that we have done...
Hello, can you hear me?
Yes, I can.
Yeah, I have a question. So now you referenced the table, the probability of death for male. And so if you'd like to reference multiple, like an array, like if it's not male, then the female, the probability of death is the female, you should be selecting, So how you can write that in the function?
So you could do, instead on the variables page, you could do either pdeathwell underscore male and then have another variable that's pdeathwell underscore female and reference the other column, which I would recommend, and then create a variable which is pdeathwell using either a if statement, or if you have a proportion of your population that is percent male, percent female, and then you'd have a third variable which is probability of death well. You could also have I'm sorry, go ahead.
There's the approx function. So currently with the lookup function, as far as I know from Excel, you always have to match the exact value. But in R, there are functions like, well, for linear approximation, I think it's called approx. So it's also possible to do some linear interpolation when looking up values from those tables?
So for the approximate function, that's where the bin at the end of the formula comes along. So VLOOKUP in Excel actually does either exact match or approximate match, depending if you give it a true-false at the end. And lookup here in heRo3 does the same thing. So by using true, we are doing approximate match.
Okay, and approximate means interpolation, or is it the closest neighbor?
No, it means the lower neighbor. So for instance, in our table, if the age was, let's say, 3.7, it would read the value from age 3.
Okay. Yeah.
Any other questions?
Here it might be helpful, okay, you refer to other packages, but to have a third option for interpolation, this might be a further plus. Yeah, okay, but great, thank you for the explanation.
Okay, so that is the example of model time dependency. But in contrast, this here, well mortality is dependent on age of the patient. But sometimes mortality is dependent on the time of being in a state. For instance, the time the patient has been sick. How long have they been sick for? So while some probabilities depend on model time, this other example would depend on state time, or how long a patient has been in a particular state. So state time dependency is usually handled with tunnel states. Now heRo3 will automatically create these tunnel states for you. So let's look at the same three-state model and consider how we could incorporate state-dependent mortality rates into this model. The tip to incorporating these probabilities, again, is going to lie in using a table of probabilities and the lookup function. So we are now going to make the table sick mortality. And this is based on the years you have spent in the sick state. So again, we have a year column and the probability of death. We'll go again to variables, and for probability of death sick, we will again use the lookup function, but reference this new table, sick mortality. And instead of using model year, we will use state year. State year and model year are both keywords in heRo3. In the heRo3 guide and frequently asked questions, there's a full table of all the keywords. They also include things like state week, state time, state month. I do not believe there's day. I would need to double check. But the point is we have one lookup based on model time, and now we have this new variable that's based on date time. So again, we would go back to our transitions, and for the probability of going to stick to dead, we would input P_def_stick, which is the variable we just created. Any questions before I move forward?
I have a question. It's not related to what you explained right now. I'm struggling with like the cycles, and in heRo3 you click like the cycle and like 1 year or a day or 3 months, 6 months. So when in R, I know when I'm building the models, and I want to flexible cycles, like the first 3 cycles, they're going to be 6 months. After that, it's going to be 1 year cycles. You could do that in R. heRo3, can I do that same thing here, or it's fixed?
Currently, the cycle length remains fixed for the entire model. There is the function rescale, which helps rescale probabilities depending on what the cycle length is. I can open up that example if that's something that's helpful right now. So for the rescale function, you can input a probability that you already have. In this case, say you have an annual probability of 0.5, and you're going from a full year and want to adjust the probability to be whatever the cycle length years is. That will adjust your probabilities. Now, it does do it assuming a constant rate over that time, but that is one way to handle if you're changing cycle length within your model. But currently, the cycle length remains the same over the full horizon of the model.
Thank you.
Any other questions before we continue forward with how to clean up the transitions sheet? Okay, so let's just take a step back, think about Markov models a little more generally. So we go to the next slide. Some early users have commented that they are unsure why the transition sheet is a long-form table instead of a matrix. And the reason we use a long-form format coupled with heRo3 convenience features, it allows you to greatly simplify some of your models. So again, let's assume that we're working in a 3-state model. It'll be a different 3-state model. Again, we have well, sick, and dead patients. In this case, our strategies are natural history and vaccine. So where the patient population is receiving a vaccination to prevent them from becoming sick. And let's assume the person using heRo3 was using it for the first time and just kind of directly input everything. They didn't think about it in advance of I should limit my variables or collapse some formulas or anything like that. So right now they have a number of variables. They have a different probability of getting sick for each year. And then they have the probability of death from sick and probability of death from well. When we go to their transition sheet, they have included a transition for every strategy from every state to every state, which actually produces 16 different lines. And that sheet is now a little daunting. So how can we clean it up? There are a few tricks to keep in mind while you're doing the transitions page. So one is, for transitions where the probability equals 0, they can be omitted. heRo3 automatically assumes they are equal to 0. There's a filtering functionality that can increase efficiency on the transitions page. There is the heRo3 convenience function C, which is equal to 1 minus the sum of all other probabilities. Also, if a transition has the same value for every strategy, you can select all in the strategy drop-down menu and use only a single row. Finally, we really suggest performing intermediate calculations on the variable page and simplifying complex conditional statements using lookup functions. So, when we go back to our model, how can we simplify this? Let's do the low-hanging fruit items first, and that's getting rid of those with a probability of 0. So in our filter, let's type 0, and wow, we now just see those that are zeros. So we can remove all those transitions. No longer need them, because heRo3 will assume they are 0 if they are not included in the list. Great, that helped a bit. Now, secondly, we're going to replace all the ones minus all the other transitioning out with C. So good thing to remember again is that heRo3 is case sensitive, and we need the capital C. Luckily, when we type C, it recommends the capital C to us. So we're going to replace all of those with capital C. Okay. Finally, let's look for formulas that are the same for the two different strategies, NAT and vaccine. So for instance, well-to-well is C in both strategies. So we can change it to all and remove the vaccine. Now since we can also do it for the probability of death sick. It's the same in both. As well as, where'd the other ones go? We have the probability of dead to dead is 1, so we can change that to all. The probability of, oops, I'm sorry, this one could have been made C. Probability of sick to sick is C in both, so that can also be made to all. And then, of course, we want to clean up the transitions sheet as much as we can. So we're going to remove the other ones once we change them. So again, probability of death to sick, those are the same. I'm sorry, sick to death. And oops, I didn't change that at all. Okay, so now everything is much cleaner. But we still have this very long if-else function. And the if-else function is looking for, based on model year, what the probability of sick is. So what we would suggest is to create a individual variable for this instead. Now, since we're running out of time, I'll just briefly show you that we would create a probability of sick in natural history with year and probability, and then in the variable sheet, we would, instead of having 1, 2, 3, 4, 5 variables, we would add a variable that would use the lookup function and reference that table that we had just created. So it's probability, C-sick NAT, and then we would fill it in based on model time and which column we want to look at, and then we could put that into the transition sheet. That would then leave us with a much cleaner variables list because we would be able to remove these 5, and the transition sheet would not have formulas going off the page. All right, moving forward, just so that we can get through at least the majority of the deck, we then have our new partition survival model. So currently, partition survival models can have only 3 states. This is something that will eventually expand to have more than 3 states, but right now we are sticking to basic partition survival models. So patients are assumed to go through these states in that order: pre-progression, post-progression, dead. And each strategy, therefore, must have two corresponding survival distributions, one for PFS and one for OS. These are used in lieu of a transition matrix in partition survival models. So you should use the survival distributions tab on the variables page to specify these distributions for PSMs. And there are three simple ways to specify survival distributions. So first, let's assume you have a Weibull function that was already fitted to your survival data. We can estimate probabilities of survival from this function using the define survival. This convenience function can produce a number of different types of distributions. The heRo3 guide and frequently asked questions lists all of them. Today we will just look at the Weibull function. And then you can also apply hazard ratios to your fitted function using apply HR. So if we go ahead and load our PSM example model, our states, again, are PFS, progression-free, PS, post-progression, PP, and dead. In this case, our strategies are chemotherapy and targeted therapy. And on our variable parameter sheet, we already have for an OS function, survival distribution, both the shape and scale. So then over in survival distributions, we are going to do OS chemo and use define survival. First you will do the distribution, followed by shape and scale. Again, if you ever forget the syntax of a function, you can go to the heRo3 guide and frequently asked questions, and it will be reported to you there. Also, just a reminder, everything is case sensitive, and R as well as heRo3 takes Weibull as a lowercase w. So then, a reminder, on our parameters page, we have already included a hazard ratio for overall survival in the target therapy. And when we go back to survival distributions, we can then apply hazard ratio to our OS chemo survival distribution. We can apply the hazard ratio for the target distribution. So the second way, and sorry I'm going quickly, I just want to make sure everyone sees. If you have any questions, please feel free to interrupt me. Now, the second way would be to assume that we have survival probabilities in the form of a KM data and consider how we can model survival. So we're going to create a table with columns for time and survival and paste in your survival data. Then we'll use the function define surtable with surtable as argument to get the survival distribution. So again, we have PFS probabilities of chemo, and we have time and survival. And then back on the survival distribution, for PFS, KM, chemo, we have, using the define survive table, we reference the survivor probabilities table. And then finally, let's assume you have actual survival data to 20.1 months, and you want to combine this data with survival projections thereafter. KM survival data can be combined with parametric survival distributions using join function. So again, we have a Weibull function for the PFS chemo, and we're going to use the join function to join the PFS KM chemo at month 20.1 with the PFS Weibull chemo. And when we go to results, you can see where the two functions have been joined. You can tell where the KM data switches to the parametric function. So next I would go into some tips and tricks for the base case results sheets unless there were any questions on the partition survival models and how to estimate basic survival distributions. Okay, so on the base case results, you have the ability to use override values to do quick one-off analyses of the sensitivity of your results to changes in any parameter value. You can override as many values as you like at the same time with this functionality. You can also, as we mentioned before, export tabular output to CSV and XLS files. I am going to go back to simplify transition, and if we go to base case, the area charts are sometimes easier to see just because there's more color. So first things first is on the right-hand side, we have this options panel. Now the options panel can be hidden by clicking on the gear icon, and it can also be shown again by, clicking on the gear icon. So the convenience of having this override value is, let's say we wanted to see how the relative risk of getting sick with after having received the vaccine affects the trace. Without using override values, we would have to go to the variable sheet and then change the relative risk value, let's say to 0.9, and then go back to the reference case and recalculate. Now, instead of going to variables to undo this, I am just going to click undo, and it will recalculate and go back. Now, to do this without leaving the results page, you can always add an override value. Again, we want the relative risk of getting sick on vaccine, and we can directly change that value here. So again, we can use undo to undo it. We can use redo to redo it. And if we want to get back just to the base case actual results, we can trash it from override values. So this is a good reason to keep things in your variables page. That is how they are referenced here. If instead we had used a formula somewhere to calculate the RR, we wouldn't be able to directly reference it. Because it's in the variables parameter page, we can reference it. Finally, for tabular exporting, if you want, you can always click just on export as XLS, and it will directly export the table. Currently, these tables do not have full precision, but the heRo team is working on increasing the precision of the outputted tables. So we do have 2 minutes left. What would be last would be to take a look at the value-based prices sheet. As part of the last major update to heRo3, we did deploy the VBP functionality. But before we go look at that, let me just let you all know that as you're working with heRo3, if you need any assistance or support, please feel free to email heRo3support@pai2.com. These slides will be sent out either later in the day or week in the coming days, so if for some reason you don't see this right now, you will have email written down. So please, again, feel free to contact us with any questions, if you need help, if you want to ask for feedback like some of you have done on this call, and we really do appreciate your continued participation in the heRo3 pilot testing study. So briefly, for those who can stay on for an additional minute or two, we can look at the VBP sheet. So VBP is right under the reference case results. And so for any willingness to pay, the model will tell you the max price that can be charged given that threshold. So here we are saying for the vaccine strategy, what is the max price we can charge for the vaccine to have a willingness to pay threshold of whichever we want to look at versus the natural history. Now, we understand this is not the best example, as you would not charge that much for a vaccine, but it's a visual example. So if we wanted to change the maximum willingness to pay, the x-axis will then adjust and the graph will recalculate. As with base case values, you can also add override values here. So if we were to, again, do the relative risk of six vaccines, and let's say we made the vaccine even better, we can then charge more for the vaccine and meet the same willingness to pay threshold. So I understand that was a very quick overview of the base case and VBP. But again, I would like to thank you all for participating in workshop number 1